trying to assemble your AL5 arm, our suggestion is to divide out all of your hardware, screws, nuts, bolts, everything that you have into like piles, because as you can see there's quite a bit of material and it's going to be a lot easier if you already have everything organized in like piles the way that you want them. As you go ahead and start assembling your base, you'll notice that you have these small ball bearings and these very small stainless steel pins that you have to assemble and put together into these 5 locations. They'll kind of snap down into place, and these are what your base plate is going to ride on to give it a little bit more range and a little bit more freedom. To increase the effectiveness of all ball bearings, what we want to try to do is remove any imperfections from the manufacturing process, smooth them out, and just level them out. The easiest way to do that is to take yourself a simple piece of sandpaper, a fine grit. We want to carefully, so that we don't dump them out, we want to carefully take the ball bearings and place them face down. Once they're onto the sandpaper, what we want to do is make small circular motions that's going to lightly sand the tops of each one of the bearings. If we carefully lift it up, hopefully none of them will fall out. And what we should be able to see is an indication, a little white stripe on each one of the bearings that shows us that they've been leveled out and smoothed out. What you want to do is kind of go around each one, making sure that the sanding marks are consistent all the way around. The next step in assembling our base is to insert the servo. As you look at your servo and you take it out of the box, the servo has a white horn already on it. Be careful as you take each one of the servos out of the box, because the servos are what we consider to be centered from the factory. At least they're supposed to be. Each one of the servos should already be set at 0, which tells us that they're already set at their home position. What we need to do for this servo is we need to take the horn completely off. Be careful when you're doing this, as you take the screw out, there's a pretty good opportunity that you're going to twist the servo just a little bit. Not a big deal for the majority of the servos, because we can either adjust them mechanically or adjust them in the software, but this one's going to be buried down a little bit deeper and a little bit more complicated to adjust mechanically. So all we want to do is take a small Phillips screwdriver. We want to take this screw directly out, being careful not to adjust the horn or trying to get it back to where we can as far as its 0 position. Once that horn is unscrewed, we should be able to pull it straight off, and that will expose the splines that are on there that are going to attach to the base plate. If we flip the base over, you're going to take your 4 3/8 long self-tapping screws, and you're going to place each one into the servo to hold it and mount it straight into the base. What I want you to notice is the servo, with this being the back, has its cord, its PWM cable, going out towards the front. That is the correct orientation that you want to be able to make your servo read correctly. What you're going to have to do is take your servo cable, you're going to have to route that around the back of your servo, around the side of the servo, and directly out the back. Once you've done that, we'll be ready to go on to the next step. Before we install the base top onto the base, this is our last time to try to make sure or ensure that each one of our bearings is going to be used to the best of its ability. Here's a good opportunity for you to just take a little drop of silicone-based oil and put that silicone-based oil on each one of the bearings. So just go around one at a time and put a small drop onto each one before you go ahead and put on the top. As you put on the top, the one thing you want to make sure is that you're putting it on in the correct orientation. So it's the same thing. You need to take a look at the base, make sure that you know where that back cut is. That's going to be what you want to turn toward yourself, and that's the one that you're going to go ahead and align this with. Now, each one of the splines that are on there are only going to give you so much degrees of freedom. You did the best you could to make sure that it didn't rotate, so what you're going to have to do is try to find where that centering is, again trying to match it up with that cutout, and you're going to have to press it into place. If it's a little bit off-centered, you may try to see if there's another spline that it can go onto or can attach to. We did a very good job of making sure we didn't lose this little tiny screw that we took out of the servo horn earlier. We're going to place that right back in. We're going to screw that into place. As you screw that into place, please be careful that you don't over-tighten that. As you over-tighten that, you're putting too much friction onto the bearings, and the bearings are creating too much friction between the plates, and you'll hear kind of a squeaking noise as the robot moves around. If you're hearing that noise, then this screw has become too tight and you're creating too much friction between those plates. All you want to do is try to make sure that the base plate cannot come off. The splines are what's going to hold it in place. All you need to do is use the screw to try to hold the base in place, or to hold this cover, the top of it, right there. Next thing we want to do in preparing our base is to try to go ahead and put together our electronic carrier. We're going to do this with some standoffs, 3/8 inch long, and some socket head cap screws across the base. We're also going to go ahead and put on our power switch bracket using 2 3/8 hex socket screws and some nylocks. Once we've done that, you'll see that you have one large hole and 2 smaller holes. That's going to be for us to go ahead and put on our toggle switch that's going to turn on and off our 9-volt power supply. And we're also going to use this time the toggle switch that's attached to the barrel plug for our wall wart. You also have the option to use the battery plug, but since this robot's not mobile, this is the one we're going to go with. While installing your switches, you want to make sure that you notice how the switches are orientated. Typically, we're going to make sure that the toggle switches are facing down to show that the toggle switches are off. Notice that you have your 2 wires coming into the switch and you have your 1 empty leg. Your 1 empty leg by default is going to be off. So we're going to make sure that both of those, for the power for the 9-volt and the power for the wall wart, are both facing up. We've also got our barrel outlet on this side. Route your wires in, and we're going to go ahead and attach the SSC32, where you're going to use 4 of those same hex screws, 1/4 inch long, to go ahead and hold on the board. We're going to route our wires nice and neat underneath the SSC32 and over to our board. Hopefully what you can notice is in the VS2 is where I've got my 9-volt power supply going. And over here into my VL is where I have my larger power wires. The one thing you really need to be careful about is making sure that these 2 power wires don't have any strays coming out, because if these 2 come in contact with each other, you can damage your power supply. We also want to make note of this jumper right here in between these first 2 terminals. We want to make sure that we remove this jumper in between the VS and the VL so that it knows that we're not trying to pull power across both of these and set up the power exactly the way we want it to be. You also want to make sure you're very careful about making sure that your polarity of both of your power wires are configured correctly. As you notice on the board, you have your negatives, positives, negative, positive, negative, positive. Your red is going to be your positive, and your black is typically going to be your negative. The last couple things we want to do in trying to prepare our base is mounting it to something, whether it be a piece of metal, perforated metal, piece of wood, whatever it is. You want to try to mount the robot around so that you've got some form of stability. We also want to go ahead and take our base servo wire and go ahead and plug that in. As you look at your SSC32, you see that you've got numbered ports 0 through 15 on this side, 16 through 31 on this side. Right now all we're going to focus on is the smaller numbers. Our base for the servo that's going to drive the base is going to go into the 0. You want to make sure that you notice the orientation of your wire, as the black ground wire should always go to the outside. You see that you've got your ground symbol here, you've got your pulse symbol on here, and you've got your voltage symbol in the middle. So we're going to go ahead and put it right onto 0. And that should finish the operation of completing our base. Once we have our base complete, next thing we have to do is go ahead and complete the arm. We're going to start with our 2 large C brackets. You have one that's different from the other. Right now it doesn't really matter configuration. And you're going to go ahead and put 2 of your 256 1/4 inch steel nuts and screws to hold those together. You're also going to go ahead and put on your friction plates. And what I want you to notice about the friction plates is on the outside you have the small hole, and on the inside you have the large hole. As you put those friction plates on, you're going to use the self-tapping Phillips screws. They're only 1/4 inch long, so you're not going to go down much into the next set of material. You really want to make sure that you hold these 2 tightly together as you push those screws through, and make sure that you don't have any gap in between either end. Now that we've got our arm built, we want to go ahead and focus on trying to attach the arm to the base. To be able to do that, we're going to go to the front of the servo bracket, and we're going to mount a bolt through that servo bracket following the instructions. And we're going to mount the arm straight to there. But you want to make sure that you have the right bolt. To be able to do that, we're going to go ahead and push through the friction plates and make sure you have enough bolt showing through to be able to put the nylon nut on there. If it's not, then you don't have the right bolt. So now comes the time where you're going to have to practice a little bit to try to get this correct. We're going to go ahead and put the nylock on there. And as I put the nylock on there, the reason we're using a nylock is so that this does have freedom to be able to move around. A regular nut would create the compression and not allow that freedom and that movement. But the bad part is you don't want to have it so loose that it doesn't have the ability to stand up on its own. What you want to do is have it tight enough to where it can hold its position, but not so tight that the servos are going to fight the ability to make this arm move. So to be able to do that, I'm going to take a small pair of needle nose pliers or a little pair of pliers, and I'm just going to tighten this up. I'm going to have to keep playing around with this joint, trying to figure out where I have enough friction on it, where I have it tight enough to where it can hold its own position. So it's going to take a little bit of trial, a little bit of error, but it's going to be very important. Right now I have it too tight, so I'm just going to have to back off of it just a little bit so that I can get it right to where it needs to be so that it can move smoothly. You also want to make sure that you put the bracket in the right orientation. You want to know that you have a small bracket up at the top and you have your large bracket down at the bottom. Your large bracket also has the larger hole that you're going to attach your mega servo to. We're now going to go ahead and put in our workhorse. This is our mega quarter scale servo. It's going to go ahead and create the shoulder for our robot. This is going to take a majority of the torque and a lot of the weight that the robot's going to work, and that's why it's such a large servo. One of the big things we want to do is before we put it in, we're going to take this PWM cable and route it right underneath the servo. So as we take the servo is going to fit on the outside of our bracket so that you can see it just here. So I've got the bracket here, I've got the servo on the outside, and I'm going to take 4 screws with washers on the outside and nuts on the backside to mount this to my base. When I'm ready to go ahead and mount the shoulder to the arm, I want to make sure that the arm is in the correct location. For the servo to be wired correctly and to be set up correctly mechanically, I need to make sure that this is straight up perpendicular to my base. And as you do that, you want to line it up with the holes that are in the servo horn, this large white horn that's here. And I should have 2 self-tapping screws that I'm going to put right into those horns after I make sure that my servo is mounted. These steps here are going to focus on the robot's forearm. What we want to do is take 2 of our hub connectors, one on both ends, and 2 of our L brackets, and connect those together. We want to make sure that we have the short side connected to the hub and the long side out. You should have symmetry to this so that you have a mirror on both ends. We're then going to go ahead and take our socket head screws and attach our aluminum tube to both of those hubs. You want to make sure that you have that as snug as you can so that you don't have a whole lot of movement in your robot. The less movement that you have, the more repeatability and the more accuracy you're going to have. You can see in these next few steps, we're going to focus on putting the 2 servo brackets onto the forearm that we just created. You want to make sure that when you put all of this in the correct orientation. So as you take a look at it, you should have your smaller bracket out on this end. You should have your larger bracket on that end, and your L brackets are going to go on top. Now we have our brackets attached. We're going to focus on the servos for attaching our elbow and our wrist to the body. We need to go ahead and put on the same type of bolt that we put on earlier, same length, and attach it the same way to the same friction plates. To do that, we want to make sure again that we have the right bolt, and we're going to test it, putting it through the friction plate and putting the nylock on there to make sure that we have the right length. We have to go through the same trial and error as we did the first time, trying to create enough friction but not too much friction. So it's the same thing. It should be able to hold itself in place, but not hold itself in place so much that the friction plates are doing too much of the work, which is going to make the servos work too hard. Just about there. Now that the elbow framework and brackets are attached, we can go ahead and attach the elbow servo. We're going to attach it in the same manner that we did our shoulder. It's going to go on the outside of the brackets, mounted with the same 4 screws, nuts, and washers. And we're going to take 2 smaller self-tapping screws and go right into to the white servo horn, making sure that we're going into the center ones of the 3. We've got 3 holes there in the servo horn. We're going to go right through the center, and we need to make sure that we are parallel to the ground as we put those screws in. This is what it should look like with both your elbow and your wrist attached. And notice that we took the same time we did with the base to route the PWM cables between the servos and the brackets. These last few steps, we're going to focus on creating the rest of our wrist. We're going to take the short C bracket and the little gripper connector. We're going to attach those with the same nuts and screws that we've been using. And that's going to go directly onto the bearing that we put onto the back side and the servo horn onto this side. But you want to make sure as you push it on that you are straight, parallel to the arm as you go onto the servo, noticing that the screw holes that you're going to use are still the top one and the bottom one in the middle for your bracket. Our last couple steps to finish up this robot is to actually go ahead and attach the little gripper. We're going to use these acorn nuts and some button head screws to attach the gripper to that mounting plate. To be able to do this right now, we can manually move the gripper open and closed. What I want you to do is get the gripper about halfway between what you think open and closed are. We're going to take our last servo that's going to run our gripper. We're going to take that screw out and we're going to remove the horn. That same spline that we've been using before is going to match up with the spline that's inside the gripper. What we're going to have to do is push it down until it matches in, and you may need to move the gripper just a little bit one way or another to match the splines up. And then we're going to go ahead and put this last screw back into place. Be very careful about this screw. This screw is very important as far as if you put too much tension down on this screw, you're going to put a whole lot of stress on the gripper. And the gripper's constantly going to be creating so much friction that it's going to burn up the servo. What you want to do is tighten down the screw. And once the screw is tightened down, I'd like for you to back the screw off just a little bit because it's the same thing. The screw isn't really holding the servo onto it, it's just holding it into place. So it doesn't have to be very tight. All it needs to do is keep it from falling back off. We're now ready to start doing some of the tedious part, which is getting all of these wires connected to the SSC32 in the correct orientation. Nice part about it is since we've already connected 0 from the base, the rest of them just kind of connect in order. You've got 0 for the base, you've got 1, 2, 3, and so on. But the big thing that you're going to realize is right now our wires aren't going to reach, especially from the wrist and from the gripper. What we're going to have to do is we're going to have to use the included extension cables to go ahead and do that. But it's going to be the same thing as far as trying to keep your robot free of the wires so that it doesn't get hung up on itself. We're going to take these same things, we're going to have to try to feed them back underneath, feed them through here, and then back down. And we'll use a couple of zip ties to bring them together so that the wires don't get caught up on each other. Once we have all of our wires routed, it's our suggestion that you take a little electrical tape and go around each one of the connections so as the robot moves around, it doesn't unplug itself. You also want to make sure that you take the robot and move it out all of its extremities to each one of its major and minor locations to make sure that your wires are not too snug or too tight. To complete this robot, we want to put on these load balancing springs. These are very vital to the robot being able to stretch out and return back from extreme positions. What we're going to need to do is replace the servo attachment hardware on both the top of this servo and the bottom of this servo and replace it with the hardware shown in the instructions. And that should complete our robot to the point where we can plug it into the software and start driving each one of the servos to make sure that we're built correctly. If not, we can easily come back and adjust it through the hardware or calibrate it through the software.